I am Ann Bowser, and I will introduce Martin and Rosie and Libby, the other collaborators in the session, after I give what will hopefully be a quick overview and a talk on my perspective on helping citizen science scale through two related initiatives, the Citizen Science Global Partnership and Earth Challenge 2020. So this is my mental model. I consider citizen science data and people for better decision making. So I see it as important for having local roots involving communities with unique contextual knowledge, but also potentially global reach through data reuse. And the process of participating in citizen science helps create education and engagement among contributors. And citizen science also offers a parallel mechanism for transparency. So this is something interesting that our community is thinking about, because we're here looking at the SDGs and we're at once interested in getting our data used in official reporting, and then also being this parallel source of information that can provide an alternate source of accountability. Citizen science has many entry points for the data piece. It can be useful for pointing to a problem. Structured monitoring campaigns provide value in situ sources of information through crowdsourcing tools and platforms for annotation and classification, are valuable for parsing big data. And then it's also important to consider the data to knowledge pipeline. For example, applying contextual qualitative knowledge to quantitative assessments. This is my logic model for what we're working on at the Wilson Center. We're engaged in global capacity building through the Citizen Science Global Partnership with the organizations that you see below. And then we also have a global activation through a concrete project called Earth Challenge 2020, which is a targeted data mobilization and capacity mobilization campaign around the 50th anniversary of Earth Day. And it seeks to collect 1 billion observations during April of 2020. Citizen Science Global Partnership, I'm just going to go through this quickly, and then Martin's going to delve into key aspects of the organization in much greater detail. So this started in 2015 when the Wilson Center and European Citizen Science Association started working, bringing people who are doing mosquito vector monitoring together, and then UN Environment joined around 2016. In 2017, we went to the third UNEA with a citizen science delegation. And this formalized in the intent to start a new network of networks, the Citizen Science Global Partnership. In March of this year, we had an IR North webinar. Thank you to this community for allowing us to join in. And then in 2019, we hope to announce an early legal structure of the Citizen Science Global Partnership at the next UNEA in Nairobi. We launched with 5 foundational goals, all of which are very ambitious. Become a coordinated point of entry for partners seeking to work with the global citizen science community, help citizen science grow in new geographic areas, leverage the consortium model of bringing different projects together to build community and share information, create a new data standard with support from partners like the Open Geospatial Consortium, and a new transdisciplinary data portal. And then, of course, it all goes back to the SDGs. Capacity in terms of geography. There are 3 existing citizen science associations in the US, in Europe, and Australia, as well as new initiatives that are emerging, such as Citizen Science Asia. Also some capacity in South America, especially around biodiversity. There have been some workshops there, and a couple projects and a couple networks that are emerging in Africa. In terms of project consortia, this is simply bringing different people who are conducting similar citizen science research together and encouraging them to collaborate on protocols, on sharing data, on sharing technology, and also on sharing effective practices around things like stakeholder engagement. So vector monitoring projects work with a certain set of decision makers that isn't necessarily the same as somebody doing air quality, for example. The activation experience, Earth Challenge 2020. This is an overlapping initiative. It's targeting 1 billion observations, as I mentioned earlier, in 5 initial target areas: air quality, water quality, biodiversity, and then looking at pollution and human health as cross-cutting issues, seeking to use this in part to demonstrate the links between human and environmental health, which is a theme that came up earlier. Our partners are the Earth Day Network, which is a very large environmental NGO. They helped organize the March for Science, and the US Department of State What's interesting about the State Department is that it isn't the policy arm, it's the people who are in charge of the US embassies and the people who put the air quality monitor on the embassy in Beijing. So they have an operational need for more non-authoritative data to complement their official sources of reporting. Other partners, including UN Environment, the Holt Prize, Open Geospatial Consortium, World Bank's Connect for Climate, and others. This is our timeline. So we've started working on a new data and metadata standard with the Open Geospatial Consortium. I think the metadata piece is more interesting. We're developing controlled vocabularies around things like data quality to help people assess fitness for use. We're doing a series of, we're launching a campaign calling for research priorities and science advisors, I believe, today. So people in Washington are busy working on press releases and so on and so forth. And this is essentially something that will go out through the Eye on Earth network as well, which is asking people around the world to tell us what are the pressing environmental research questions, including those that also impact human health, that the community can sort of coalesce around. We're having a series of hackathons in 2019 so people can build the technologies, including a mobile app, but also things like APIs to help join and contribute to the efforts. Also work on a what you can do toolkit that's going to link participation to action in terms of individual changes, and then also policy levers. 2020 is data collection. 2021 is an exciting opportunity to step back and look at the data that we've assembled and start to evaluate our impacts. This is the infrastructure piece of the puzzle, the Citizen Science Cloud. This is my personal involvement and something that I am probably the most excited about out of anything in this slide deck. So we're building a new open transdisciplinary citizen science database that's going to be embedded in an API-enabled cloud infrastructure. Data comes in through a couple sources, the new mobile app, direct upload into the database, and then linking existing open data assets through APIs. And we see two major use cases for getting data out using a platform like GEOS that facilitates integration with Earth observations and also brings in certain research and decision-making communities, but then also working with mapping platforms, either produced by the private sector or UN Situation Room. It's an open data environment, so you can pull it out in multiple ways, but sort of visualizing that information and packaging it so that a range of audiences can take advantage. I just described that and that. This is the timeline, and this also connects the two initiatives. So the 2020 data points in April 2020 will sort of, the 1 billion data points in April 2020 will sort of create the open data asset, and then by working through the project consortium model and also the activation of new geographic networks, we can continue to loop together existing data sources and continue building community and capacity throughout this process. Also starting to do a real push for legacy information. So it's not just from 2020 onward, but pulling in some of the old and very valuable data. And these are the impacts that we hope to have. Strengthening capacity through technology and community at local to global levels, while creating virtuous feedback loops, enabling more projects and more participation. As one of the five core pioneers in setting up the European Citizen Science Association, Martin is a former senior manager and executive officer in both the private and public sector. He has various advisory roles to the UK government and EU public sector bodies, European NGOs, global multinational companies, and UK and EU trade organizations in Belgium, Portugal, and Greece. And he currently operates as an independent environmental consultant for the Citizen Science Global Partnership, among many other hats of service to the citizen science community.
I wanted to set in context what we're trying to do now in the Citizen Science Global Partnership. And one of the things I haven't heard a lot of at this particular event is the report from the IPPC, which really made the urgency for change abundantly apparent. The next few years are probably the most important in the history of mankind in taking decisions on the environment. There's Deborah Roberts, co-chair of the IPPC working group. And then the second one, we're all already seeing the consequences of 1 degree C of global warming through more extreme weather. That was on the 8th of October. And if this will work, let's try it this way. It's not advancing, I'm afraid. Can somebody help me advance the slides?
It's harder than it looks, right?
You have to do it that way. Okay. So if we then go to the 10th of October, you had deadly flash floods hit Mallorca. On the 11th of October, the US Hurricane Michael slammed ashore in the Florida Panhandle. On the 12th of October, Storm Callum hit a rain bomb, causing worst flooding for 30 years in Wales. On the 14th of October, for only the 5th time ever recorded, a hurricane hit Portugal. And on the 15th of October, flash floods killed 10 in the southwest of France with another rain bomb. And on the 23rd of October, freak storms hit Rome. And if you see the photograph here, this is Rome yesterday under ice and hail after a heat storm. So it's almost as if the weather is telling us that the predictions made by the scientists are actually coming true as we speak. Now, I know you can explain away some of these in statistical probability terms, but all of them following on in that sequence is telling us that something is changing in the climate. Okay, so what that tells me is that if we're going to have any chance of meeting the targets that's being set for climate change, we have to engage with the citizens. We have to get people involved. We have to get people involved in the SDGs. It's no longer an abstract concept, because what we're actually talking about is changing people's behaviors. We're actually asking the citizen to start thinking about the consequences of climate change. So we want the citizen to be different, to stay ahead, to be a first mover, to be a citizen scientist, to be one of the billion that we expect to take part over the next few years in citizen science. And the reason citizen science is so critical to our future is that it's a different way of doing science. Generally speaking, if it's well set up, it's cheaper, it's quicker than conventional data gathering methods, it's more agile, it's as accurate as conventional science. And for me, citizen science is the future. If you're not engaged in citizen science, you're not going to be able to deliver the types of changes that we expect to see. And the other thing that's happening in our society is that there's something called the fourth industrial revolution approaching. And this is a quote that you can actually get access to online, which is talking about what the implications of that fourth industrial revolution will mean for the community. And the quote is, "We stand on the brink of a technical revolution that will fundamentally alter the way we live, work, and relate to one another. In its scale, scope, and complexity, the transformation will be unlike anything humankind has experienced before. The speed of current breakthroughs has no historical precedent. And the possibilities of billions of people connected by mobile devices with unprecedented processing power, storage capacity, and access to knowledge are unlimited. It's why I see citizen science as the future." So what does that mean for the Citizen Science Global Partnership, which is a network and support consortium that we've set up to try to bring together and scale up some of the best examples of national citizen science programs into potential global programs? The concept is very simple. Do it once, do it right, do it with the same tools, do it with the same apps, do it with the same database systems. Do it local, make it global. Do it with the United Nations. And develop common business models that will work at the global scale, because there is real difficulty in taking national programs up to global programs. And we first experienced this in the Mosquito Alert Consortium, and the partners are all shown on this particular slide. This is a very real problem in terms of the consequences of climate change and also our mode of international travel, allowing mosquito species to move into Northern Europe, into Northern America, bringing with them the risk of disease, the Zika, chikungunya, yellow fever, dengue fever, bringing potentially malaria back into some of these areas as well. And what we've already seen is at national level, there are excellent citizen science programs that are already running. This is the example from Spain. And in Spain, the program has already proven itself, and there have been articles in Nature that have been peer reviewed, that it's a reliable system, it brings you good data, it enables you as an environmental health professional to link in with citizens to work out where the risks are and to deal with the behavior change that's required of citizens to reduce that risk. Or we can go up to the Netherlands or into Italy. And Italy's already had disease outbreaks in Rome as a result of the invasive mosquito species. And we can see how you use the power of citizen science. And the best example is the one in the Netherlands, where they monitor for mosquito bites from ticks and mosquitoes, and they put the results on the weather forecast. So the weather forecast in the biting season has the weather, the pollen count, and the mosquito and tick count. And the impact in the Netherlands was quite amazing. The way you communicated the information provided by the citizens, and then it self-generates more citizens to take part in the programs. In Italy, they use a website, and it doesn't have anything like the effect of getting the communication systems right for the citizen science program. But they're learning from one another. So you've seen something similar to this. This is the timeline to show you how you start to bring national programs up to global level. And we started in 2015 because we were asked by the Americans if they would join with us to steal our best ideas on citizen science and apply them and add value. And there's nothing wrong in that. That's exactly what we should be doing. But we had to tell them we didn't have a European program. We had 5 different programs running in Europe using 5 different techniques, 5 different databases, 5 different apps, and we were not learning from one another. We brought the groups together with the support of the UN in Geneva. In 2016, the UN offered. 2017, the workshop was finally set up, and in 2 days, the citizen science community agreed standard methods for monitoring mosquitoes as a citizen science approach. I was told it couldn't be done in 2 days, by the way. But the urgency from representatives that the UN brought to the same meeting from countries where mosquitoes were endemic was urgent. And they got that across to everybody that was there. They wanted to simply take what we had and use it straight away. They wanted to translate it. They wanted support from us to be able to grow this into global programs. And we didn't have the resources to do that. But we did have the resources to agree and publish the results of the program and the workshop that we held in Geneva. And we now have standard methods agreed between all the participants that we would like to roll out to the rest of the world. We also had another program running, a data metadatabase system to help us manage the accuracy and the management of the data, so that not only can we roll out the methodology for citizen science monitoring, but we can make sure the data is sound. So we can take proven citizen science programs to the global stage. These are programs that have been peer reviewed, where the data is accurate, where the volume of people getting involved can be very large. We can put together custodians to identify common global systems. We can offer open access tools, metadata protocols, and standards. But we need to experiment with business models that will fund global rollout. We're stuck with the mosquito program at the moment in wanting to go to global rollout. So we need business and commercial partners prepared to share costs and benefits, public sector partners prepared to work long-term with the program. This is not a short-term program. It's not a 3-year funded project. Or we need private foundations prepared to provide that long-term support, or we need to be bold and secure crowd-based funding solutions that are beginning to emerge for citizen science programs, or a combination of both. So my final slide is to say, if you're in business and commerce and you're interested in working with us, we need partners to help us navigate the next stage. And I'm going to lead on now to other colleagues who will open up a wider debate on some additional areas where we may be able to take national programs into global programs. Thank you very much.
Next up, we have Libby Hepburn. Libby is co-chair of the Global SDG and Citizen Science Maximization Group established under the European Citizen Science Association, or ECSA. She was also an instigator and founding member of the Australian Citizen Science Association. Locally, Libby developed and manages a long-term biodiversity monitoring and mapping network of 400 community members and expert moderators, and has extended this to create a regional network and communities of practice in Australia.
So I'm going to talk to you about the formation of the Global Working Group on SDGs and Citizen Science Maximization. But I think it's worth just reflecting. Everybody here knows what citizen science is, but even those of us that work in it all the time are constantly amazed by the breadth and the scope of it. We probably think of citizen science as being people who are doing water quality or looking for water bugs. But you can do, the bottom left-hand corner is an illustration of people doing citizen science in Antarctica. Or this is Antwerp. People are actually doing air quality monitoring in Antwerp. And there are projects out in the Amazon and in Africa where the apps that people are using don't have words on them, they have illustrations. So people can use them for recording what they have in their own areas to prove that it's worth saving. So there are all sorts of things that happen in citizen science, and the scope is enormous. You probably also know about Zooniverse, which was started as a project to look at the images that were coming back from the Hubble telescope. And so far, and this is probably out of date now, but we've got 20 million records that have been looked at and checked and rechecked by people online. There's way over 1 million people have been involved in this project. It's all online, and they've discovered 34 new star systems, new kinds of stars and things. So these are people engaging in online citizen science. But it can be much different to that. It can be people who have real health issues, who get involved because their children are being made ill by water pollution or something like that. And you probably also know the Flint story of what was happening there when the people providing the water changed from a water plant to taking water out of the river, and all the issues that were caused. Have a look at The Crowd in the Cloud. It was a television series that was made in America, and that gives you a really good cross-section of all kinds of different citizen science projects. So what we've seen is a huge increase in citizen science over the last few years. And over the last few years, people have come together to work together to promote citizen science, so more and more people can get involved in more and more different ways. And these are just associations that have been formed in the last few years. I don't think any of them are older than 3 or 4 years. So this is fast. And Alex Caldas, who you saw in the last session through there, he gave us a video for the Australian Citizen Science Conference. And this was, I have to say, was really the first time I'd heard about SDGs. And what he was saying was that he believes citizen science can have a great effect, great impact on the SDGs, because it focuses on data. It's important in a timely and powerful way. You can have lots of things that happen real time, as we talked about the mosquito project. It's a people-centered approach. This is through citizen science, you can get the community involved, and it's transformative, leaves no one behind. But also, it's a very innovative activity involving all kinds of different kinds of partnerships. So this was the background to it, and after that we looked at it, and we could see what was there in terms of the scope of the 2030 agenda and the SDGs, and also we could see very clearly that citizen science has a big role to play here. So after the European Citizen Science Conference earlier on this year, we came together, and it was obvious that we needed a global working group to try and bring people together so that we could help to move things forward. So that's what we set up. And within 3 weeks, we had 82 members. And if you look at that, it's from Cameroon to Chile to Canada. These people, all we did was to put it out through the Citizen Science Association networks. We didn't advertise it at all. But we were amazed by the number and of people that were interested in contributing to the SDGs through citizen science right across the globe. And these were the initial objectives, the initial ideas about what we needed to do to maximize the benefits both to the SDGs and also to citizen science. We needed to know where we fit in with the SDGs. And we needed to know what was required in terms of data and metadata. And we all agreed that what we can offer that is perhaps different is that we work bottom up, we work with the community on the ground doing things, but we also need to work top down with the UN and international organizations who are already working in this field. And it's been fascinating to come to the Eye on Earth Symposium and see just what is happening in this field and how many people are involved in it. So these are the things that we know we need to do: advocacy and awareness raising, big exemplars of things that can be done on the big issues, but also we are working for the practitioners. We're not just working to give information to policymakers. We actually want to make it possible for more people on the ground to get involved. So we know we need practical things for them. And one of our members of the working group was Thomas Oabrate, who works with the World Meteorological Organization, and he's involved in the indicators for water. And he said, we need to see what citizen science can add into the water SDGs. So we started looking, we set up a cluster group to look at what's going on in water. And it's very evident that already there are significant numbers of people are involved. It's one of the key issues, obviously, but there are significant numbers. This is an Earthwatch project that's been going, I think, 9 years. No, maybe longer than that, 2004, I think it started. And this is just an example from Victoria in Australia, the water, the funding that's been given to water quality monitoring over the years. And we've got data that goes back 30 or more years for water quality. It's really interesting to see that data exists already, and there's lots happening already in this area through citizen science. And that already the data that citizens are producing is used in decision making. So it's there already, and the proof of it is in the fact that they are using the data. So what we understand, what we are seeing more and more, is that there are many, many contributions that citizen science can make to the SDGs. They can make them large on a global scale through multiple and ladders of complexity of different methodologies. They can be made local, which is really important, and they can be made in long time series with multiple projects. There are many techniques. I mean, citizen science, we all say technology is a great enabler for people to be able to make a contribution. And the things that are happening in technology just blow you away every day. So as Martin says, we are in the middle of a revolution, and it's moving really fast. Citizens can do what the satellite data can't do: ground truthing and field surveys, getting people on the ground, getting them to actually look in detail at things, different levels of granularity to add to the data. And these are some of the projects that I think are obvious ones that we should be looking at, that we've been told by the UN are ones that we need to be having a look at. So there are many, many more. And we have an issue because there is huge amounts of data, there are huge amounts of data in terms of citizen science projects, but how do we make those data discoverable, and how do we demonstrate what the quality is? That's one of the big issues that we have, is that it's been collected by all sorts of people for all sorts of reasons for a long time, but it's all out there. So what we need is FAIR, which I'm sure people have been talking about this over the last couple of days. And once we can demonstrate the quality of citizen science data, we can offer what's being done to this point in time. We can also say what's possible in the future. As we said, we need to give practitioner support, shared methodologies, guides and toolkits, and resources. As Martin said, we need to be able to offer models and ways and resources to take the projects global, because the power of citizen science is that you can engage huge numbers of people over large scales. And this is a slide you've already seen. The Citizen Science Global Associations are working on data and metadata, and I've been given permission to say that the first data standards for citizen science data and metadata are going to be launched in January. So we can offer huge things to the global SDG community, things that are different from any other kind of organization, any other kind of movement. And we really want to work with people across the SDGs. So what we're saying is we have this working group, we've identified things we need to do to help our community. But what we'd like to hear from is the external SDG community coming and talking to us about how they would like to see citizens more involved and how we can help them to do that. So that's mine. Oh, no, it's not mine, that's the same as the last one. Okay, thanks.
Thank you, Libby.
So we have heard a lot about the status and the plans of citizen science in terms of policies, standards, partnerships. So I'm going to use my few minutes here to just go very concrete and very deep in some examples on how citizen science could contribute, and in some cases it's already contributing to the Sustainable Development Goals. So let's start with one, goal 14, sustainable use of oceans, seas, and marine resources. And if you look at target 14.1 is reduce marine pollution of all kinds. And then if you go even deeper to the specific indicator 14.1.1 is about, well, coastal eutrophication and the density of floating plastic debris. So this is one of the indicators which is tier 3. I guess you are all aware tier 3 means that there is not really a methodology agreed on how to collect the data and how to go about this indicator. And here is, I just extracted a few suggestions from the people actually working on this. And you can see they go from surveys to looking at existing data, looking at data from satellites. So the good news is that actually a lot of projects already exist in citizen science that are tackling this. And we did a small exercise a couple of weeks ago in Vienna, and we spent about an hour and a half just looking for projects. And we have more than 40 projects that came out that are doing exactly this, looking at the quantity of marine debris. And they do it in very different ways, taking samples from the beach or samples of water, using drones, using artificial intelligence. And these are projects that are local and global. They are started from universities or centered on NGOs. So really a little bit of everything. And a big shout out to Australia. They are really having an amazing coordinated effort of more than 1,000 organizations involving a lot of people. But I would like to go deeper in one of these of the Australian studies. This is a study that was finished in 2016, a couple of years ago, and they involved students, about 7,000 students from schools, and they were collecting debris in random places along the coast of Australia, but with criteria, of course, of every 100 kilometers and a certain number of debris. And they did, training for the people participating of just one day. They did a deeper training of the teachers and some of the representatives just to structure. And the goal, what is interesting is that the goal of this project was to see if the data collected by the citizens could be used by official organizations. So data quality. And if you went to any of the sessions here that mention, citizen-generated data quality is the first thing. So this study was doing exactly that. They published on a peer-reviewed paper, and their conclusion was that the data collected by citizens were of the same quality of the data collected by experts, that the students were good enough, they collected small samples with the same precision, again, an expert, and actually, sometimes the citizens were more efficient than experts in terms of speed and coverage. So what I'm trying to highlight here with this first example is the following thing. Why this worked? because when you talk about citizen science as a form of citizen-generated data, what you get as a bonus is a scientific methodology. So behind citizen science project are scientists that have been doing this for 100 years with citizens and know what they are doing. So they don't improvise, they try different protocol and then try again and they look at the error. And this is a procedure that comes with citizen science. Second example, so goal 6 is again water. 6.3 water quality, reducing pollution in water, and 6.3.2 is again measure of the quality of water. So why water? Is obvious, water is everywhere. I mean, if you really want to measure on every river, every lake, I mean, like there is like no way that scientists or official organization can handle this. This is such a natural place to involve citizens. And that, sorry, is again tier 3. Actually, I think it's been moved up to tier 2. So I think they actually agreed on a methodology, but up to a few months ago, this was still not clear how they would handle that. And again, the good news is there are a lot of projects that are already handling this in citizen science. And again, they go from huge, global initiative like the Earth Eco Water Challenge, which used to be called the World Water Monitoring Challenge, which is involving citizens, is like going to their local streams or lake. There is the Global Microplastic Initiative, which apparently holds like the bigger sample of data of this kind existing on Earth. And then you have very small initiative like the one in Kenya, where basically is around, the Mau forest. And in this particular case, they're simply asking citizens to go and read some values on gauge that have been placed there and to send that information by SMS. Again, I just would like to go deep on just one example. This is the Freshwater Watch from the Earthwatch Institute. Again, a big project with sites in the UK, in Europe, in Africa, more than 9,000 citizens, 2,000 water samples, 20,000 water samples. So we are really talking about big numbers again. And there is one thing in particular that they do, that are these water bleeds, where they actually concentrate all of the effort. I don't know if you are aware of what biobleeds are. Basically, in 24 hours, you just all over the place, you ask citizens to do and, to go and take measurements. And this allows a geographical coverage in a measurement that no other methodology can really reach. And this is, again, geographical coverage of citizen science effort. And of course, even in this case, it was very scientific. There is a publication, data have been compared to data from experts, and people, in leading positions, especially this example was on the River Thames in London, is just the kind of data that they could have with this project was unprecedented. So what their conclusion and the way they could use data was only possible in this way. Another aspect, which is something that we tend to ignore because somehow it comes as a byproduct of citizen science and somehow it comes for free, is all of the educational component of what you are doing. So in this particular case, in the Freshwater Watch case, they actually did a survey with 450 participants, and you can see the impact in terms of understanding the problem, reducing your impact, motivating citizens. So what we're talking about is, as a byproduct of a citizen science project, you basically get education, awareness, and change of behavior in the citizens. Last example, this time is air pollution, goal 11. In the cities, so 11.6 is about what is waste management and air quality. And again, this particular indicator is about measuring the presence of a PM 2.5 or PM 10 particles. This is tier one, easy. I mean, there is a methodology, there are data, one can think, okay, so at least in this particular indicator we have, well, unfortunately, it turns out that just a couple of weeks ago, basically, actually a few months ago, 6 EU countries were actually called to court because they were not complying. So maybe, yes, they do have data to measure what is happening, but then basically they have not the strength to do anything about it. So one other project, just about scaling, this is my last slide. This is a project that started in the Flanders, in Belgium, in Antwerp. I don't know how to pronounce the name of the city. Anyway, just with 2,000 citizens. And it was about measuring, the quality of air. It was very successful. The data were used as input into the modeling of the consequences of air pollution on Earth, and the quantity of data that was produced really allowed to improve all of the parameters of the simulation to really see the consequences. It was so successful that has been extended to the whole region, the Flanders region in Belgium. So we are talking about 50,000 families that volunteered and actually paid 10 euros to participate. So again, they're not only volunteering, they're actually paying to help you. And so 50% of the population participated in this, very successful again, and now the Netherlands are considering to actually extend this at the country levels. So I will stop here. There are thousands of examples. We can just go on, but I will stop here and give some time for the questions. Thank you.
Who would like to start?
Hello. So my question really is about attitudes towards citizen science and specifically kind of data security, because one of the things that comes up when I mention citizen science, and particularly technology-based citizen science with people who are not already into it, is they may be worried that that data that they're using or data about them could be used by someone with ill intentions, or people are a bit worried at the moment about how their data is used. And I was wondering if you guys had any thoughts about that.
Everyone's looking at me. Would you mind, could all people ask questions, please also say their name and affiliation for those on the webcam.
Oh, yeah. My name is Arabella Willing, and I'm the co-chair of the Emirates Natural History Group.
Thank you. I think that's a great question. And data governance issues are coming to the forefront both at this forum and as we're thinking about the architecture for the Citizen Science Cloud. And one of the solutions that we're considering is having the core database be separate than the data platform. So people can share information with the database, which would be open in many cases, but not necessarily all of them, because some projects will want to manage sensitive information and not make all aspects of it public. And then data contributors would be able to opt in to sharing their data with the larger Citizen Science Cloud, making that information or a subset of that information open and available for everybody to access. And we're also looking at solutions like blockchain for doing sophisticated provenance tracking. So if I submit a single observation of a bird that's hanging out around this venue and somebody wants to reuse that piece, even if I license it as open data, I could get a ping back that would essentially ask me to reconsent to share that information with the data requester.
Yeah, just to what Anne just said, I wanted to complement something. So in one project we are doing as part of an EU-funded project called We Observe, we have developed quite a sophisticated way of anonymization, or whatever the word is called, of the personal data. So one critical thing what you were mentioning is that people don't mind if their data is to some degree used for science, but they don't want any personal data to be shared with anybody. And there are very sophisticated and interesting techniques using crypto names, for example, that this is no more possible, but at the same time you still want to know how good this person has performed. So you want to be able to potentially cluster. So you want to know, you don't know anymore the name of the person, but you know that this person has maybe done extremely well in the past and is likely to perform well in the future. So you want to know that, and you want to keep the knowledge, and that is really important. But at the same time, you don't want and you want to guarantee. So with this method we've developed, you guarantee the person that it's GDPR compliant and that personal data is known by nobody, not even by the person running the system. So this is the clever way which we developed in this project.
I have a question, and I wish Derek were still here. I know he popped in and popped out. What is the role of the Eye on Earth community specifically for facilitating the global growth of citizen science? It's for anyone in the audience or on the panel who would like to tackle it.
Everyone is scared, so I will give some reflection.
And what's your name and affiliation?
My name is Kostas Torregas, and I'm from the George Washington University in Washington, D.C. I'm a long-time participant in Eye on Earth. I wanted to answer your question with a process answer. Tomorrow evening, we're at the very end, after the plenary session is finished next door at the WDF, we're going to have a 45-minute session that's called Expanding the Reach of Eye on Earth. And the intent is to have all of us that have participated in these really good discussions to talk about the need for and the shape of an Eye on Earth movement that goes beyond, let's say, webinars and a portal, and talks about maybe a more strategic direction for Eye on Earth in areas where we, as the users, the participants, feel it can help. Eye on Earth is a significant organization with a long history. It goes back to 2009, 2010. 5 very important organizations are the alliance that guides it. But I think tomorrow afternoon I would invite all of you to attend this discussion about expanding the reach of Eye on Earth and be able in a way to respond to your question. I know that Eye on Earth has done very small steps. It had a couple of webinars on the topic, and I think it attracted hundreds of people from around the world and advanced the knowledge part. But what about, I'm much more action-oriented. I'd like to kind of do something and maybe form new alliances and move the ball a little bit forward. So I think I'm an enthusiast for Eye on Earth. That's a warning. So I'd invite all of you to come tomorrow afternoon. Thank you.
Thank you. I have a couple of, one question and one is a comment. My first question is really how to get citizen science to be recognized by government and, you know, to start see credibility in making decisions based on citizen science. What's your thoughts on how we can get the governments to believe in citizen science? This is my question. My comment is, I'm not sure it's like a question or a comment. Citizen science is complemented by social innovation. Does the two work together, social innovation and citizen science? Because, you know, social innovation is really finding solution based on participatory approaches of the community. And citizen science is more, have more into the detailed scientific aspect. Social innovation is the mind rather than the scientific aspect. Thank you.
Let me come back to you on the first one. There is a session, the second session on citizen science, where we're starting to drill into some of the issues around citizen science and the SDGs, and I'm going to finish it with looking at some of the examples of how you build citizen science into government decision making. There is a book that's just been published, believe it or not, on citizen science that has a whole chapter on how you can successfully integrate citizen science into government decision-making processes. And what it really comes down to is creating an institutional framework that is endorsed from the top of the organisation to drive citizen science into the daily job of that organisation. And the best examples come from the US, where you now have the Crowdsourcing and Citizen Science Act 2017, which has embedded the legal obligations and made sure that there are no legal impediments to federal agencies embedding citizen science in their day job. There are examples now in Europe where the European Union is beginning to embed citizen science into the policy-making, decision-making process and the delivery process. So one of the great things about citizen science is it can actually help you to demonstrate whether your laws and regulations are actually working on the ground in a real partnership between the regulator and the citizen. And there is a working group, for instance, of the heads of the environment agencies across the whole of Europe looking at how they use citizen science in their day job. And they're drawing on best examples from Ireland, from Scotland, from Finland, where they're doing exactly what you're talking about. And if you have a look at the book that's been published, it gives you all the best case examples of the methods that have been used in different parts of the world to start to embed citizen science into government decision making. I wouldn't say that every model is applicable in every country, because it's clearly not. But you can draw on the experience of those who've already done it to see what's right for your country to build citizen science into that overall process. I'd finish by saying that there are also some fantastic projects out there which have deliberately gone out to get social inclusion in citizen science projects, and then there is no barrier if the project is designed correctly to any segment of society taking part in citizen science. Indeed, some of the most inspiring examples I've seen on citizen science have been where the marginalised communities have got involved only to realise that they can influence science, that they can influence decision making in a way they never expected was possible. So again, it really depends how you set your project up as to which groups you attract to it. But the days when it was just the amateur professionalists that got involved in citizen science are over. This is ordinary people getting involved, sometimes the marginal communities getting involved. And these are the communities very often that will tell you where the emerging environmental problems of tomorrow are, because they live with them. You know, most of us don't live with these issues, but they do. And they're only too willing to take part.
Hi, my name is Glenn Harrington. I'm with the US EPA. So I was just curious what your thoughts were on developing citizen science in a place, either a location where citizen science hasn't really been used previously, or I guess maybe also in a topical area where citizen science hasn't been used. How can you incentivize people to start providing that kind of data?
Well, usually you start from self-interest. And that's why something like air quality seems to be one that hits the sweet spot for people, because it affects them. So if you can find something that affects them particularly, then they'll get involved. And the big thing about citizen science is that it's voluntary. So you'll only get people involved if they think it's meaningful. And people do spend a lot of time helping you if they think the project itself is meaningful, but they spend a lot of time helping you if they think it's meaningful for them as well. So it's finding the sweet spots for us to demonstrate the big projects, you know, the ones that are really going to make a difference to the SDGs.
Closing thoughts from the other two panelists on the social piece or the final question?
Well, I can just say something about the social piece. For Geneva, we work a lot with students. And what we do basically is starting from challenges on how to use citizen science and open data in certain issues or problems, which are usually given to us by the UN. Being in Geneva is kind of simple. Then we have students, we coach students, they work around projects, and for projects that really make sense from the social point of view, we even have an accelerator. So we are really a lot of activities on transforming this methodology into some real social innovation with some real support, at least our experience in Geneva.
I can cite the example of Tanzania, especially not from the government, but from WWF. We are working with community a lot. And we have taken a step to help the government to collect, for example, marine fish catch data. But they are not terming it as citizen science. So there is a lot of activity within citizen science, but people, they don't know they are doing that. So that's WWF we are trying to use. So in wildlife, in whatever. In water quality a little bit, because it's coming from South Africa ministers. They know it's a citizen science. So there is this streamlining people to understand that in the community that they are doing citizen science. But a lot we're depending on them. We are distributing this mobile phone development application. For example, we are training Forest Watch to collect data about forests. So there is a lot, but taming and citizen science, that's still, because there is no real framework to do that. That's what we are struggling right now to do.
Thank you.